Hello and welcome to another sorting algorithm in Python. Today I'm going to show you how to do quicksort. As you can guess from the name, quicksort is a quick algorithm. Uh, it's actually used in like Java and Python is their default sort function. I think it does to any like major languages. I'm not sure, but it does actually have a possibility of running an n squared time. But normally the high probability is to be in n log n time, which is pretty good for, actually very good for large data. So let's get started. First thing we gotta do is we gotta choose the pivot. Pivot's important because if you choose the worst pivot every time, you can get n squared time. But right now we're just dealing with random numbers, so it doesn't really matter which pivot we choose. We'll just choose the first one, 3. We're going to break it into a list now, and then we're going to get pointers on the left and the right side. And what we're going to do is we're going to move closer to the center. And if the left pointer finds a value that's greater than the pivot, and the right pointer finds a value less than the pivot, it'll swap those two numbers. Okay, so let's just see how that works. So we start from the left. We go, our focus is on 1, that's less than 3, that's great. Then we go to 5, that's greater than 5. So now we have a left pointer. Let's go to the right. We get 7, 7's greater than 3, no problem. And then we get 2, 2 is less than 3, it's a problem. So once we find a value for the left pointer and a value for the right pointer, we'll swap them. And it'll look like 1, 2, 5, 7. Then after that, we put our pivot in the middle. So as you can see, every number to the left is smaller, every number to the right is larger. Actually, right now it's sorted, but that doesn't usually happen. What would normally happen was you'd run quicksort on this list and then quicksort on this list. Because quicksort is a divide and conquer algorithm. And it just recursively runs through each list until it's all sorted. So let's get to the code. So I have a random list going, and I started off. Our arguments are a list, our beginning and end pointer. These will be integers. They'll represent the index. These aren't values. So let's check first if begin is less than end. Okay, and then we'll grab our pivot. That's going to equal, this is going to be a function, we'll write this later. But it's going to take the same parameters, begin and end. Now we got to run quicksort on the left side. So quicksort, we'll use the same list, and we'll start from the begin, and we'll go all the way to 1 left of the pivot. So that'll be p minus 1. And then we'll run it again on the right half of the list, and we'll start at p plus 1 and go all the way to end. Okay, and then once all this is done, we'll just return the list. Okay, so that's all we have for our main function. Now let's write our pivot function. It takes a list, begin, and end. Okay, so let's get our pointers. Let's get a pivot, and remember we're just dealing with random data, so it doesn't matter which one we choose. Equal likelihood of any of them, so we'll just set that to be the first one. Well, left pointer, that's going to be begin plus 1. And the other one is right. We can just set that to end. So now we have our pointers. Let's get a while loop going, and we'll break out of this later. First we got to find our left index we're using. So while we got to make sure left is less than or equal to right. Also the value. So we're not checking index anymore, we're actually checking the value in the list. So list at 0 will be 1, and we'll compare that to the pivot. And we want to make sure it's smaller to move on to the right. So list at left, it's less than or equal to the pivot. If this is true, we'll move to the right. How do we move right? We just add 1 to it. Okay, let's do a similar thing with the right. We can just use this. Come on. Sorry. And list at right. Now we want to make sure it's greater than the pivot. Now if this is true, we'll just move 1 to the left. We'll just minus equal 1. So at this point, we found 2 pointers that we can swap. Now, but if left less than right, we're done basically. So we'll break out of it. Else, we'll swap them. So I'm just going to copy a bunch because I don't like typing. I probably spend more time copying and pasting than typing, but whatever, it's done. Okay, so we have our while loop, we have a way of breaking out of it. Okay, so that's it. Now what we got to do is put our pivot value into the middle of the list. So I'm going to type it out this time. So our beginning value, we're going to swap that with the right. So right now it's the leftmost right value, so it's in the middle, so we can swap it. And we'll swap that with the right. And now we can return the pointer we were using. So we chose the right. So okay, now we have a way of getting our pivot and running it. Let's see if it worked. Quick sort. Run the list. What do I do? Okay, we'll start at 0 and we'll end at length of list minus 1. Okay, let's see if this worked. Okay, it's caught in the while loop. Let me think. It's got to be a problem up here. Less than. Okay. So problems here. If left is right, left is less than right, then there's nothing wrong. We gotta make sure it's greater, because if it is, then we break out of it. So I think that was a problem. And there we go. So our lowest number. Okay, this is probably too big of a list. 69. I'm just kind of checking them randomly. Actually, let's be fancy about it. List. Okay, I'm just going to run through it, and if one value is bigger, then I'll break it and write a message. So range. So if sorted list at I, if that's ever greater than sorted list, sorted list at I plus 1, that's ever true. Let's print wrong and just break out of it. Okay, let's see if it works. Sorted list. Let's run that again. Okay, I'm not seeing the word wrong. So yeah, I think that worked, and that is Quicksort. Thanks for watching.